Welcome. This is an introduction overview video of the Physical Science Can I Believe My Eyes PS1 from iQuest. And the goal here is just to kind of give you a brief overview of what is going on in this unit so that you know where the big picture is as you're running through it. So this is a 27 to 28 class period unit. It's about 8 weeks long when you think realistically about all the things that happen in our day. And the big thing about this particular unit is it's the very first unit, if you follow the sequence that iQuest recommends, it's the very first unit that students will be introduced to in 6th grade in the fall. And so they will be introduced for the first time to the driving question board, the word wall, the importance of questioning within iQuest, this idea of scientific principles and how they develop their own scientific principles. But then the unit, in order to do that, or with the science concepts that are being used in this unit, are basically an introduction to the electromagnetic spectrum and primarily through visible light. And so we're going to use this really very simple, common understanding of how we see and how do our eyes work and how does light interact with that, so that students have something they can observe, they can take data and start making meaning of this seemingly basic concept of light, but is quite more complicated than we first think of it. The wave model of light will be introduced at the very end, and modeling is the big scientific practice. While there are certainly other practices included in this unit, modeling is the big one. It's broken up into 4 learning sets. The first learning set, how does light allow me to see? So how does that part work? Learning set 2, what happens to light when light reaches an object? How can light have different colors in learning set 3? And then, is there light I cannot see? So there will be a little bit of information about non-visible light at the end, but it's a very secondary piece. Lesson 1 is the anchoring activity and driving question board. And they will be, most iQuest units, if you haven't used them before, they're really set around this first activity that is a common phenomena that all students can relate to and get to start to develop their ideas around this particular unit. So in this particular unit, they get to see this crazy moving circle image, and the students ideally, actually, as I think about it now, I'm realizing my image here has the little moving circles thing at the top. Ideally, you would have it set up so they can't see that, because you want them to make just straight up observations. So what's going on here? You have a discussion around this. The students get kind of freaked out by it. Some of them gets headaches. It's all good, but how is it moving, and why is that working? Is it really moving or not? And then you do the checkerboard, which is the one that really messes with my brain. You ask basically, are A and B the same? And most people say no, A is darker, B is lighter. But then when you start to block out the light around, you will see, oh, it's already starting to change, isn't it? To the point where they almost look the same. And in fact, they are the same color. And it leads us to the driving question board. And this is how I set up my driving question board. I have a big board in the back where I set them up, and then we kind of get students to start asking questions. Well, what's going on with the light? What questions do you have about light? And then you post those up on the board. And so those sticky notes are all individual questions that students have asked, and they get to have their thoughts put up on the board, and then you can revisit those as you go through the unit and start answering those questions, ideally, as you go through the unit. In lesson 2, what do we need to see an object? We develop this idea of what are the main components you need in order to see anything. And it starts off with these light boxes. They're basically shoe boxes with holes in them so that you can see through the opening down here, and you start off with this little flap that's over here. You start off with that closed, so when they look through the hole here, they can't see anything because there's no light coming in, which is part of what you're trying to get them to see. Then you open the flap, and they're able to see that there's a little bear in there, whatever figurine you have. And then you can add in these little barricades or blocks that'll kind of cut off certain portions of the object, so it makes it harder to see, and have a discussion around that. And then you get into this really basic setup of, well, what allows this girl to see the tree? And that hopefully students will see, okay, there's got to be some sort of light source, you need an object to be seen, you need a person or an eye to see, and you need this straight path so that the person can see it. And they often don't get that particular one, so if they don't get this straight path, clear path, and there's another image here where they have this little wall, and that helps to say, well, why can't you see the car now? And that helps to bring out the idea that, well, you need to have a straight path. There's a lot of misconceptions at this point. Students think there's something coming out of the eyes. There's a lot of students who feel like, well, I can't see the car because my sight is being blocked, and they don't really understand that it's really the light that's being reflected off the car can't get to the eye. But that's okay for now. Don't try not to correct that. Don't validate it either, but allow that to still happen, and the students allow them to kind of work through that process. There's going to be a lot of work on that. They'll develop their first scientific principle here, and so again, these are the four main ideas of what you need in order to see an object. However, one of the things I want you to notice, if you go back and I show you the driving question board that I came up with my students, you'll notice that we had light, yes, and we had eyes, and we had nothing in the way and objects, but they also my students felt it was really important that we make the point that the object needs to be close enough. If it's too far away, you still can't see it, regardless if you have the other four things. And that's okay. The point is not to hit only those four and to have it be exactly the way it's worded in the book. The idea is that the students are generating this idea. And I use clear line of sight. They use nothing in the way. And it's their definition, their principle, and they take then ownership of that, and it becomes theirs. In lesson 3, students will construct models of how people see. And you'll start off with a little simple model of light, where this little clay object in the middle is supposed to represent a light bulb, and the little toy cars are supposed to represent the light coming out of the light bulb. And you ask them the question, well, models have their strengths and weaknesses. Is this a good model? Is it a bad model? What makes it good? What makes it bad? And they're able to say, well, cars don't necessarily represent a good model of light, but maybe because they have this idea of motion, maybe it is okay. And so they are going to start, and they will develop their own 3D models of sight and light.